Okay, so this is Chemistry Chapter 11, and this video will be on the review problems at the end of Chapter 11 of your textbook. And again, like before, we're just going to work the problems that are in there. So let's start with number 7. 7 has 3 parts, so the first one is this. Okay, so that's the first one, and for question number 7, we are asked to identify the acid and the base. Okay, so if we look at this compound and then look at the product over here, we notice that this goes from an H5 to an H6. So that means that this compound accepted the hydrogen ion, and since bases accept hydrogen ions, then that would be the base. And then the water this went from H2O to just HO or OH. So this donated the hydrogen to this. So this would be the acid, the proton donor, or the hydrogen ion donor. Okay, so that's 7A. 7B, we have this. Again, we're looking to identify the acid and the base. So let's look first at this. So this H6 becomes H5. So it gave away a hydrogen ion. So that means that, it gave away the hydrogen ion. So that means that that is the acid. I'm sorry, I wrote this wrong here. This should be H3O, it should be the hydronium ion here. Okay, H3O. Okay, and then the water went from H2 to H3, so it accepted the hydrogen ion, and therefore the water is the base. Okay, so in 7A, we saw water acting as an acid. Here we see it acting as a base. And remember, the term we use for that is amphoteric or amphoprotic. Okay, then 7C, we have this. Okay, so HCN becomes CN. So that it donated they got rid of its hydrogen, it donated it, so this would be the acid. And pH3 goes from pH3 to pH4. It accepted the hydrogen, so it's the base. Okay. So look for what happens to the hydrogens. Chase the hydrogens around, see where they went, and that will tell you which was the acid and which was the base. Okay, number 9 gives us a series of compounds, and we are just asked to identify them as acids or bases. Okay, NH3, you're supposed to memorize that. That's ammonia. It's a base. HNO3. Okay, that's an acid. Starts with an H, and it's a so it can donate 1 hydrogen ion. This. Okay, that also is an acid, and in this case we pull the hydrogen that can be donated out to the front. So even though it has 6 hydrogens, only 1 of those hydrogen ions gets donated. Okay, lithium hydroxide, so this OH tells us that's a base. And then next is zinc hydroxide. And again, the hydroxide tells you that's a base. Okay, number 10 says, suppose you are told by a chemist that citric acid, so this is the formula for citric acid. So suppose that you are told by a chemist that citric acid can donate 3 hydrogen ions. How could you rewrite the chemical formula to make citric acid more recognizable as a polyprotic acid? Okay, so polyprotic means an acid that can donate more than 1 hydrogen ion. Okay, and so we're told that it can donate 3. So the way you would write that is you would pull 3 of those out like that. You can leave the carbon where it was. Now you have just 5 hydrogens and then the O7. Okay, so just pull the number of hydrogens out that can be donated and put those on the front. Okay, number 11 says HBr is a strong acid and it will make water act as a base. Okay, so HBr is the acid, and in its presence, water acts as a base. What is the chemical reaction between those two? Okay, so this is the acid. It's going to donate the hydrogen to the water, and that becomes H3O, which is a hydronium ion, and then we have the bromine left over. And then I think that's balanced. So we have 3 hydrogens, 1 oxygen, 1 bromine, 1 bromine. Okay, number 12 has 4 parts. We're to write the reaction that occurs between the following chemicals. So 12A is H2SO4, which is sulfuric acid, and NH3. And so looking at this, you should recognize right away that this is the acid because it has the hydrogen on the front, and you've memorized that ammonia, NH3, is a base. So the hydrogens are going to be donated to the NH3. That will become NH4. And then you just have the sulfate left over. And then you have to balance it. So 6, if we put a 2 here, that gives us 6 hydrogens and 2 more is 8. So let's put a 2 there. That gives us 8 hydrogens. It also gives us 2 nitrogens, and we have 2 nitrogens here. And then the SO4 is okay. Okay, so that's 12A. Okay, 12B is the reaction between HF and aluminum hydroxide. Okay, so again, you should recognize this is the acid and this is the base because it contains those hydroxides. So the hydrogen from the acid will be donated to that hydroxyl group to become water. And then what you have left over is the aluminum fluoride. And you have to look at the charges to see how that should be written. So aluminum's charge is +3. Fluorine's charge is -1. So we switch those charges. So the 3 comes over here with the fluorine. Okay, now we can balance it. So if we put a 3 here, that fixes our fluorines. The aluminums are okay. Hydrogens, we have 3 + 3, that's 6. So if we put a 3 here, that's 6 hydrogens there, and then we have 3 oxygens and we have 3 oxygens. So that is balanced. Okay, 12C is the reaction between H3PO4 and calcium hydroxide. Okay, so again, the acid here, this hydroxyl tells us that's the base. So these hydrogen ions from the acid will be donated to the hydroxyl to make water. And then what we're left with is the calcium phosphate, CaPO4. So when we look at the charges, calcium has a charge of +2, and the phosphate has a charge of -3. So we're going to switch those charges. So it's going to become Ca3. So 3 calcium atoms and 2 of the phosphates. Okay, then we got to balance it. So let's see, we have 2 PO4s over there, so let's put 2 here. Now we have 6, 7, 8 hydrogens over on the reactant side, so let's put a 4 here. Let me erase that, make that a little more clear. So if we put a 4 there, now the hydrogens are okay. Calciums, we got to put a 3 there. So now we're going to mess that up. Let's see, 6 plus, oh no, hydrogen 6 plus 6 is 12. So this has to become a 6. And now we look at the oxygens, we have 4 plus 3 times 2 is 6, that's 10. 2 times 4 is 8, plus 6 is 14, and we have 6 plus 8 is 14, so that's balanced. Okay, and then the last one for number 12, so 12B, is H2CrO4. And magnesium hydroxide. Okay, so here's our acid, here's our base because of hydroxyl ions. So we're going to make water and salt. So you'll have magnesium chromate. And I know chromate is not on your list. It actually has a charge of -2, and magnesium has a charge of +2. So that's the way, since both numbers are the same, we just leave them off. So now we can balance this, and I think it may already be balanced. So 4 hydrogens. That's why I just put a 2 there. And now everything else I think is okay. The chromine, CrO4, one of those. Magnesiums are okay. Oxygens, we have 4, 5, 6, and we have 4, 5, 6. and we have 2 plus 2, 4 hydrogens and 4 hydrogens. Okay, so that's the balanced equation showing that. So an acid plus a base gives us water and a salt. Okay, number 13. You see 5 clear solutions and you're given the pHs as being 0.1, 4.5, 7.0, 9.0, and 14.0. Okay, and then A says one of them is a solution of sodium chloride and water. Which one? Okay, so sodium chloride is an it's an ionic compound, and so it's salt water, and its pH would be about 7.0. One of them is a very concentrated solution of a strong acid. So its pH, the stronger the acid, the lower the pH. So it says a very strong acid, so it would be 0.1. One of them is sour but pleasant to drink. So it's sour, so that tells us it's an acid, but we enjoy drinking it, so it's not too acidic, so it would be a pH of about 4.5. One of them is a glass cleaner that you can buy in the supermarket. Okay, so again, it's a base, but not a really, really strong base. So it would have a pH greater than 7, but not as high as 14. One of them is a very caustic base. Which one? So that means a very strong base. And so the 14.0 would be the very strong base. Okay, number 14. So number 14 says, what volume of a 3.17 molar solution of H2SO4, which is sulfuric acid, would be required to neutralize 750 milliliters of a 2.12 molar solution of sodium hydroxide? Okay, so we need to recognize for this problem that we are given some information about sodium hydroxide and we are asked some information about sulfuric acid, H2SO4. Okay, so right away that tells us we're going to use stoichiometry. Okay, so the best place to start is to write your chemical reaction and get it balanced, because you can't use stoichiometry without the balanced chemical reaction. Okay, so it's a reaction between H2SO4 and sodium hydroxide. Okay, so acid, base, because of the hydroxide, because of the hydrogens. And these hydrogens are going to form water with the, I'm going to come over here and join up with those, that hydroxide is going to form water. And then you're going to have a salt, and the salt that's left over is sodium sulfate. Okay, and we need to make sure that we have written the sodium sulfate correctly. So the charge on the sodium is +1, and the charge on sulfate, sorry I don't have, is a -2. Okay, so we're going to switch those charges, so it's going to be, the 2 is going to go with the sodium. It's going to be Na2SO4. Okay, now we need to balance it. I'll erase this. Let's go ahead and balance it. We can start with the sodium, so let's put a 2 there. SO4s are okay, sodiums are okay. Let's look at the hydrogen. So we have 4 hydrogens over here. We have 2 plus 2. So let's put a 2 there. And then let's look at the oxygens. We have 4 plus 2, we have 6, and we have 2 plus 4, we have 6. Okay, so that's the balanced equation. Okay, then what information are we given? We are given that for the sodium hydroxide, we have 750 milliliters. And it's a 2.12 molar solution. Okay, and then all that we are told about the sulfuric acid is its concentration. So it's 3.17 molar, and we want to know how many milliliters or liters is required for that. Okay, so we're going to use this information to figure out the number of moles of sodium hydroxide. Okay, so molarity is equal to moles over liters. So we want to solve for moles, so we're just going to multiply both sides by liters. So molarity times liters equals moles. The molarity is 2.12. And remember, moles over liters is what molarity is. And we'll multiply that times the number of liters. So we got to convert this to liters. Just move the decimal place 3 places to the left. Divide by 1,000. So it's 0.750 liters. Liters cancel. And you are left with 3 significant figures, 1.59 moles of sodium hydroxide. Okay, now with that, now that we have it in moles, we can do stoichiometry, and we're interested in how many of these there are, so that's going to go on top. So there is 1 H2SO4 for each 2 sodium hydroxide. Okay, so the sodium hydroxides cancel. So 1.59 divided by 2 is 0.795 moles of H2SO4. Okay, so now we know that there are 0.795 moles of this. Okay, and now we can use this equation to determine the liters of that. So let's make us some room. So we want to know liters, so we're going to rearrange this equation for liters. Okay, so liters cancel there, multiply by liters over here, and divide by m. So divide both sides by m, that gets rid of it there. So liters is equal to moles divided by molarity. Okay, so the number of moles we just figured out was 0.795 moles. And the molarity given at the very beginning was 3.17 molarity, which is the same as molarity is moles over liters. Okay, so moles are going to cancel, you're left with liters. And if you do that math, you should get 0.251, with 3 significant figures, 0.251 liters. And the problem actually asked us for milliliters. So that would just be 251 milliliters of H2SO4. Okay, so we started, this information was given, we used that information to get moles of sodium hydroxide. Once we had moles of sodium hydroxide, we used stoichiometry to get moles of this. So then once we had moles of this and we were given molarity, we could use that to determine the number of liters. So if you have 750 milliliters of a 2.12 molar sodium hydroxide solution, and if you add that to 251 milliliters of a 3.17 molar sulfuric acid solution, the solution will be neutral, have a pH of 7. Okay, number 15, the last one. A student needs to neutralize 1.5 liters of a 5.6 molar HCl solution. So that's your acid. How many grams of aluminum hydroxide should be used? So again, we are given information about hydrochloric acid, HCl. We're asked about aluminum hydroxide, so that's a stoichiometry equation. So the first place to start is to write the chemical reaction. So it's a reaction between HCl and aluminum hydroxide. Okay, so HCl is the acid. It's going to donate its hydrogens to the OH group to get water. And a salt, so what you're left with is the aluminum chloride. Okay, so then we need to look at the charges on the aluminum. The charge on aluminum is +3. The charge on chlorine is -1. So you'll switch those charges, so the 3 is going to come down there with the chlorine. So it's AlCl3. Okay, now let's balance it. So to fix the chlorines, we'll put a 3 here. So now if we look at the hydrogens, we have 4 on this side. So we can, is that right? Oh, I'm sorry, I didn't write this correct. This is a 3 here. Yeah. So now we have 6 hydrogens on this side. So let's put a 3 there to get 6 hydrogens there, and then we have 3 oxygens and we have 3 oxygens. Okay, so that's the balance equation. And then what are we given? We are told that we have 1.5 liters of this. And so that's the volume, and we have the concentration at 5.6 molar. Okay, so we'll use that information to get moles. So 5.6 moles over liters, that's what molarity is, times 1.5 liters will give us the moles of HCl. And with 2 significant figures, we get 8.4 moles of HCl. Okay, now that that's in moles, we can use stoichiometry to determine the number of moles of this. So 8.4 moles of HCl and there is 1 aluminum hydroxide for each 3 hydrochloric acid, HCl. So the HCl's cancel. 8.4 divided by 3 is 2.8 moles of aluminum hydroxide. Okay, the problem asks us for the number of grams. So now it's just a matter of converting those moles to grams. So let's look at, we have aluminum, 1 aluminum, 3 oxygens and 3 hydrogens. So it's going to be 3 times 16, 3 times 1.01, and then the aluminum is 26.98. Okay, so 1 mole of aluminum hydroxide is 78.01 grams per mole. So I'm just going to scoot this over here, just give us more room. So it was 2.8 moles of aluminum hydroxide. And there are 78.01 grams in a mole. So moles are canceling grams, and what you'll get 218 point something. But we can just have 2 significant figures, so your answer would need to be 220 grams of aluminum hydroxide. Okay, and you could also write this 2.2 times 10 squared grams. Those are your answers right there. Okay, so we're not doing questions 15 to 21, so those are the that's the last of the problems for review for chapter 11.